A spontaneous reaction will occur with no input of energy. An example of this would be something like elephant's toothpaste, in which you just put the reactants together and it explodes. In the opposite way, a non-spontaneous reaction does require the input of energy. An example of this would be photosynthesis, in which a plant takes in the energy from the sun in order to produce glucose and oxygen. You can determine the spontaneity of a reaction by looking at the oxidizing agent versus the reducing agent. If the oxidizing agent is higher on the chart than the reducing agent, then it's like rolling a ball downhill. It doesn't require any energy. If the oxidizing agent is below the reducing agent on the chart, it will take a lot of energy in order for the reaction to happen. It's like rolling that same ball uphill. You can also determine the spontaneity by comparing the oxidizing agent voltage versus the reducing agent voltage. The voltages can be found on the chart in the data booklet. You will determine the cell potential by subtracting the reducing agent from the oxidizing agent, or cathode minus anode. If the cell potential has been determined to be a positive, then the reaction is spontaneous. That means it requires no energy. It will actually produce that much energy. If the cell potential is negative, it's a non-spontaneous reaction. It will require at least that amount of energy that you have calculated in order for the reaction to occur. If you add more energy, it's known as cell overvoltage. That will just speed up the reaction. Let's do an example. We're going to react copper nitrate with aluminum solid. Step 1, we need to dissociate the ions. Then we're going to find them on the chart and determine our strongest oxidizing agent and reducing agent. Nitrate, if you notice, is not on the chart. Our strongest oxidizing agent is our copper 2+. Our strongest reducing agent is our aluminum solid. We're going to write down the half reaction straight up out of the chart. From there, we're going to balance the electrons, and we're going to put the reactions together. Now that we have our total redox reaction, we can calculate the cell potential. We're going to go strongest oxidizing agent minus strongest reducing agent. And we're going to read them right off the chart. We've determined that our cell potential is 2 volts, and it's a spontaneous reaction. In a spontaneity test, reactants are tested to observe spontaneity, shown through an observable chemical reaction. The reducing agents are often solid metals. They're along the top of the chart. In this example, your oxidizing agents are most often identified as cations. The presence of a reaction, denoted by a check mark, indicates the oxidizing agent is above the reducing agent. In this example, B positive is the strongest oxidizing agent, and A solid is the strongest reducing agent, as it reacts with everything.